By the 19th century, enough evidence had accumulated in favor of atomic hypothesis of matter. In 1897, the experiments on electric discharge through gases carried out by the English physicist J.J. Thomson revealed that atoms of different elements contain negatively charged constituents called electrons and that are identical for all atoms. However, atoms on a whole are electrically neutral. Therefore, an atom must also contain some positive charge to neutralize the negative charge of the electrons. But what is the arrangement of the positive charge and the electron inside the atom? In other words, what is the structure of an atom? That was the question raised by that time. Okay. The first model of atom was proposed by J.J. Thomson in 1898. According to this model, the positive charge of the atom is uniformly distributed throughout the volume of the atom, and the negatively charged electrons are embedded in it like seeds in a watermelon. This model was picturesquely called plum pudding model of the atom. However, subsequent studies on atom as described in this chapter showed that the distribution of electrons and positive charges are very different from that proposed in this model. We know that condensed matter such as solids and liquids and dense gases at all temperatures emit electromagnetic radiation in which a continuous distribution of several wavelengths is present. This is with different intensities also. This radiation is considered to be due to the oscillations of atoms and molecules governed by the interaction of each atom or molecule with its neighbors. In contrast, light emitted from rarefied gases heated in a flame or excited electrically in a glow tube, such as the familiar neon sign or mercury vapor light, has only certain discrete wavelengths. The spectrum appears as a series of bright lines. In such gases, the average spacing between the atoms is large. Hence, the radiation emitted can be considered due to individual atoms rather than because of interactions between atoms or molecules. So, there arises a difference of continuous distribution and discrete distribution. So, we cannot account this continuous distribution of radiation to our consideration. In the early 19th century, it was also established that each element is associated with a characteristic spectrum of radiation. For example, hydrogen always gives a set of lines with fixed relative position between the lines. This fact suggested an intimate relationship between the internal structure of an atom and the spectrum of radiation emitted by it. In 1885, Johann Jacob Balmer obtained a simple empirical formula which gave the wavelength of a group of lines emitted by atomic hydrogen. Since hydrogen is the is simplest of the elements known. We shall consider its spectrum in detail in this chapter, atom. Ernst Rutherford, a former research student of J.J. Thomson, was engaged in experiments on alpha particles emitted by some radioactive elements. In 1906, he proposed a classic experiment of scattering of these alpha particles by atoms to investigate the atomic structure. This experiment was later performed around 1911 by Hans Geiger and Ernst Marsden, who was 20-year-old student and had not yet earned his bachelor degree. The details are discussed in next sessions. The explanation of the results led to the birth of Rutherford's planetary model of atom, also called nuclear model of atom. According to this, entire positive charge and most of the mass of the atom is concentrated in a small volume called the nucleus, with electrons revolving around the nucleus just as planets revolve around the sun. We will discuss this model of atom in detail in the next classes, and that will upload in this YouTube channel. But we can consider this experiment and its success as a milestone in the history of searching of an atom. Rutherford's nuclear model was a major step towards how we see the atom today. However, it could not explain why atoms emit light only discrete wavelength. How could an atom as simple as hydrogen consisting of a single electron and a single proton emit a complex spectrum of specific wavelengths? In the classic picture of an atom, the electrons revolves around the nucleus much like the way a planet revolves around the sun. However, we shall see that there are some serious difficulties in accepting such a model, and we will discuss the next model. And there you can see there are merits and demerits of that model, and as time passes we will change everything according to our knowledge. So that is the course of science and history of science.